Welcome back. We are still in topic 6, still under differentiation, because even though it's a new topic, it is still a part of, it's taught as a part of differentiation generally, even though it could be an independent topic on its own, it could also be under coordinate geometry as well. The thing we're talking today is parametric equations. Another headache for whether it is differentiation or integration, parametric equations are always or coordinate geometry for that matter. Why did parametric equations come into being is very important, because suppose you look at the question x power 2 over 3 plus y power 2 over 3 equals a power 2 over. And you also sketch this curve. Also find tangent at a point. Tangent into x equal to 1. Where will you go? It's almost impossible, right? Whereas, if I were to say x equal to a cos cube theta, y equal to b sin cube theta, let's see what will happen. So this will become a power 2 over 3 cos cube theta power 2 over 3 plus a power 2 over 3 sin cube theta power 2 over 3 equals a power 2 over 3. Cos cube theta power 2 over 3 is cos squared theta. So I can remove a power 2 over 3 common factor. I get cos squared theta plus sin squared theta is equal to a power 2 over 3, which is true. In other words, instead of working with this equation, we can work with this equation. That means, even though x and y are connected directly, it's more difficult to work with x and y than with the trigonometric functions. So here, something like a is related to b, related, not friendship. B is related to C, so A is related to C. Yeah? So it's an indirect, whenever the variables x and y are defined in terms of a third variable, then the set of equations is called a set of parametric equations. And this theta is called a parameter. In fact, curves like this prompted, or something like, you see, you had x squared over a squared minus y squared over b squared equal to 1. Then, as it is going to be difficult to solve, whereas we could use x equal to a sec theta, y equal to b tan theta. Then we can solve more, it becomes easier to solve or work with to get, because this particular curve is a hyperbola, is like that, with asymptotes and everything. People doing further maths would know about it when you do coordinate geometry. So that's the purpose of parametric equations. So in other words, when x and y are defined using a third variable t, then the set of equations is called a set of parametric equations. There's no definition. I don't have to write the definition. So let's go step by step. Number one, I want to show you how to sketch parametric curves. Where will this be useful? If you have a 14-mark question on integration, part A will be sketch the curve, blah, blah, blah. And then next part will be the region bounded by the curve and the x-axis and blah, blah, blah. So remember, when you sketch, you are still sketching x and y. You are still sketching x and y, but the values of x and y, the table you get, depends upon the parameter. So parametric equations, I can say x equal to f of t, y equal to g of t. But there will be, so in other words, the values of x and y, the domain and range both depend upon the value of t. Let's take part A. X equal to t squared plus 1, y equal to t plus 2. You're asked to sketch. Of course, you can spend your whole lifetime giving values and finding points, but makes sense. Generally, what I suggest is put values from, with its algebraic function, put values from -3 to 3 to get the shape. Okay? What is x? X is t squared plus 1. 10, 5, 1, 0, 1, 5 and 10. As you can see, the graph is symmetrical about the x-axis. T plus 2, -1, 0, 1, 2, 3, 4, 5. Correct? Is it correct? T plus 2, -3 plus 2 is -1, -2 plus 2 is 0, -1 plus 2 is 1. Yeah. And remember always, plot and join in ascending order of t. You don't look at x and y, you join ascending order of t. So therefore, I have an x-axis, I have a y-axis. Oh my god, I forgot to start my watch, stopwatch. So I think I've taken about 5 minutes. So what I'll do will be, I will do this lesson for about 12 minutes. Okay, by the way, as I am setting up, my name is Sosale Mohana. I'm a maths teacher with over 50 years of teaching experience, teaching mainly A-level maths and further maths. So I'm just doing questions or topics on A-level pure maths to help you people prepare for your exams and to revise what you have been taught in school. So coming back to that, 10 and -1, 2, 4, 6, 8. Now when it's a rough sketch, but still please show some divisions, and y values go up to 5, yeah? So -1, 1, 2, 3, 4, 5. Okay? 10 and -1, 5 and 0, 1 and 1. Oh, that is 2, 4, 1 and 1, 0 and 2, then 1 and 3, and then 2 and 4, and then 10 and 5, somewhere there. So roughly, me and my graph. So roughly the graph is like this. Ascending order of t. Sometimes they say showing the branch of the curve for t less than 0, t equal to 0 and t greater than 0. So this is t less than 0, that's t equal to 0, that's t greater than 0. Let me take another example. Okay. This lesson, I'll just show you how to sketch curves. X equal to 3 cos theta, y equal to 2 sin theta. Of course, they will obviously mention 0 less than or equal to theta less than 2 pi. Even if they don't mention it, you assume it generally. Now, this is where the problem comes. You can't make a table. Only with algebraic make a table. If not, what you do is take values of x, standard values from 0 to 90, and then use the behavior of sine and cos to sketch the curve. So we do it that, I mean, the sketch carries only 1 mark, so don't worry. When theta is 0, x is 3, y is 0. And try to put this, because when you do integration, it becomes necessary. And when theta is, let's say, 30 degrees, x is 0.86 times 3, 24, about 2.5, and y is 1. So 1, 2, y is 1. Do you realize this is where you need to learn to think? As theta increases, value of x goes from 3 to 0. The value of y goes from 0 to 2. So the biggest value of y is 2, the biggest value of x is 3, the smallest value of y is minus 2, the smallest value of x is minus 3. So this graph goes like this. You can get some points put as 30, theta equal to pi over 6, theta equal to pi over 4, and then theta equal to pi over 3, and then theta equal to pi. Of course, this is not for further math students. This is theta equal to pi over 2. Further math students should know the graph of that. Is x squared over 9 plus y squared over 4 equal to 1, which is an ellipse. Now, the biggest value is minus 3. The biggest value there is minus 2. As theta increases from, look, I am joining the ascending order of theta. This is y-axis, that is x-axis. As theta increases from 90 to 180, x decreases further from 0 to minus 3. So x will go to minus 3, y will decrease from 1 to 0. And then as you go from 90 to 270, x will increase from minus 3 to 0, y will decrease further from 0 to minus 2. As you go from 270 to 360, x will increase from 0 to 3, y will increase from minus 1 to 0. That's your graph. It's an ellipse. So trigonometric graphs are a bit of a pain, as I will show you in the next one. I want to switch over. One algebraic, one trigonometric. One algebraic, one trigonometric, so that you get used to all. The next one, interesting one. Part C, x equal to t squared minus 1, y equal to t cubed minus t. Of course, it says t belongs to R. Good. So as usual, I make a table for t. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Let's write the values of x. 9 minus 1 is 8, 4 minus 1 is 3, 1 minus 1 is 0, minus 1, 0, 3 and 8. Very good. Now values of y are interesting. Values of y, t cube minus t. 20 minus 27 plus 3 is minus 24. Minus 8 plus 2 is minus 6. Minus 1 plus 1 is 0. 0, 0, 6 and 24. Hey. So you have to plot. Here I can't make a scale. Going to be a bit of a problem. So 8 and minus 24 somewhere there. 3 and minus 6. Let's say that's there. 1, 2, 3 and minus 6. And then 0 and 0. Then minus 1 and 0. Again 0 and 0. Then 3 and 6. And then 8 and 24. Look, your graph comes up like this. And you see, it's not a straight line. So it can't go there. So what happens between these two? That means I'm wondering what happens between these two. So to do that, 3 and minus 6, 0 and 0. Between 0 and 0 and minus 1 and 0, so I'll take minus half, minus 0.5. 0.5 squared is 0.25. 0.25 minus 1 is 0.75. Somewhere there, negative. And then 0.5 cube is 0.125. 0.125 minus 0.125. Minus 0.125 plus 0.5 plus 0.375. So it's a point somewhere there. Now look, as you see, the graph goes up there, but it has to come to 0. Once it comes, it can't again go back. It can't go in a straight line, so it has to come down there, go up there, go up there. There was a past paper question where you had asked to find the area of that loop. Sketch the curve. That was way back in 1980s, and find the area of the loop found by the curve and the x-axis as a line of symmetry. So this is t less than 0, and minus 1, 0 is t equal to 0, and this one is t greater than 0. Yeah, interesting curve, isn't it? I've got 2 more to do. 9, I said I'll do about 5 minutes or about 15 minutes maximum. So the next one is a straightforward question, but we need to know certain things. That's why I'm taking this. Part D is x equal to cos theta, y equal to cos 2 theta. No domain given, but we assume domain table 0 to 2 pi. There's a reason why I'm taking this. So at theta equal to 0, x is 1, y is 1. Do you realize that? 1, 2, 3, 4, 5. That's 1. See, biggest x is 1, biggest y is also 1. Yeah? At theta equal to pi over 4, x is 1 over root 2, 0.7, y is pi over 2, 0. So 0.4, 0.2, 0.4, 0.6, 0.8, 0.7 and 0. You understand that? Up to 45 degrees. At 60 degrees, x is half, y is minus half. So x is 0.2, 0.4, 0.5, y is minus half. Yeah? And then at theta equal to 90, x is 0, y is minus 1. Boom, somewhere there. So I know this part of the graph is somewhere like that. What happens beyond that? I mean, of course, I should have drawn a nice graph somewhere, doesn't matter. What happens beyond that? When x is, say, 120, it's minus half, and then y is 240, minus half. So minus half, minus half. At x equal to 135, x is minus 0.7, y is 0. So do you agree this graph comes like that and goes like that? Now this is why I took this graph, was to show you where you can go wrong. Generally, I have seen when I sketch, some student will have realized, look, cos 2 theta equal to 2 cos square theta minus 1. So y is equal to 2x squared minus 1. That I know how to draw. So this is minus 1 over root 2. That's 1 over root 2. That is minus 1. That graph is like this. That's a perfectly correct graph, but I will give you B1 for that, B1 for that, B1 for the shape, but B0 for the final answer. Why did I give you 1 mark less? Yes. Can you tell me why? Be careful. X cannot go beyond 1. Y cannot go beyond 1. That means your graph cannot be drawn beyond 1. By you have exercised your poetic liberty or artistic liberty to draw a huge graph, you lose a mark because the domain and range are still within 1. Be careful. That's the reason. So be careful, especially when it is a trig function. You have to make sure you don't go beyond the possible values of x and y. So don't give in to your artistic temperament. Doesn't work in maths. Right. When I introduced the question, I took a very interesting example called the asteroid, which is x equal to a cos cube t, y equal to a sin cube t, 0 less than or equal to t less than 2 pi. In fact, it's astronomers in the olden days use this curve because it looked like an asteroid. In fact, there was one curve, I can't remember the equation. I think theta minus sine theta and then cos theta minus something. I've seen a curve like this. Beautiful parametric equation curve. I can't remember the name now. Anyway, that's not what I'm drawing now. Just out of interest, parametric equations are very interesting. So t equal to 0, x is, remember I'm going to put the limits. Always learn to put the limits so that you know your graph cannot go beyond this. At t equal to 0, x is a, y is 0. At t equal to pi over 2, x is 0, y is a. At t equal to pi, x is minus a, y is 0. At t equal to 3 pi by 2, x is 0, y equal to minus a. So you know that, 4 points. But then, at pi over 4, cos and sine are equal. So, at pi over 4, it will be a point on the line, look, 0.7a. So that's 0.5, 0.7a somewhere there. Alright? 0.7a somewhere there. And this, if you take some values and plot, it will be a graph like that. Put x is equal to, it's 0.7 cube, you see, that's why. It's going to be like that. And then, once you do it by symmetry, you can draw the graph. People doing further maths in A level, generally either surface area or arc length. That's a very standard question. That is how it's in the shape of an asteroid. That's why. So in other words, what you do is take values of t from 0 to pi over 2, sketch that, and then use a graph that as t increases, x decreases, goes negative, comes back to 0, back to 1. Y starts from 1, goes to 0, goes to negative 1, comes back to 0. So use the behavior of sine and cos curves to sketch this. In the next lesson, I thought I will be able to show you how to convert Cartesians to polars. I'm sorry that I'll have to do in the next lesson, so I'll see you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.